Hello dear student, this is Mr. Hitesh Patel, Assistant Professor LJ Institute of Engineering and Technology. In this channel we will discuss the subject BME, Basic Mechanical Engineering. Okay, today in this video session we are going to discuss about some numericals of internal combustion engine. In last video session we have discussed 4-stroke petrol engine, 4-stroke diesel engine, 2-stroke petrol engine and 2-stroke diesel engine. Today in this video session we are going to solve some basic numericals of internal combustion engine. So let's start with the numericals. So this is first numerical. The following readings were taken during the test on a single cylinder 4-stroke oil engine. Okay, so the cylinder diameter is 270 mm, stroke length 380 mm, mean effective pressure is 6 bar, engine speed is 250 rpm, net load on the brake is 1000 Newton, effective diameter of the brake is 1.5 meter, fuel use is 10 kilogram per hour and CV means calorific value of the fuel is 44,400 kilojoule per kilogram. Now we need to calculate the brake power, indicated power, mechanical efficiency and indicated thermal efficiency. Okay. So first of all, we need to discuss some basic concept like what is brake power. So brake power is the power available at the engine crankshaft. The power which is available at the engine crankshaft is known as brake power. Indicated power means the power which generated inside the engine. The power which generated inside the engine cylinder, that power is known as indicated power. Mechanical efficiency is defined as the ratio of brake power to the indicated power, and indicated thermal efficiency eta IT is equal to indicated power divided by mass of fuel multiplied by calorific value of the fuel, or we can say the eta IT is equal to IP divided by MF into CV. CV means calorific value. Okay, so step by step we will solve this numerical. So you can see here they have given us diameter D is equal to 270 mm, so it is 0.27 meter. Length, stroke length is 380 mm, so 0.38 meter. Mean effective pressure is 6 bar, so it is 6 into 10 raised to 5 Newton per meter square or Pascal. Net load, RPM is 350 RPM. Load on the drum is 1000 Newton. Diameter of the rope is 1.5 meter. Diameter of the brake drum is 1.5 meter. Mass of the fuel is 10 kilogram per hour and calorific value of the fuel is 44,400 kilojoule per kilogram. Now we need to calculate brake power and indicated power. So let's start. First, the indicated power. Indicated power means IP is equal to PMLAN divided by 60,000. Okay. But this is 4-stroke engine. So small n is equal to capital N by 2. So we need to divide the RPM of the engine. So by putting the value of PM, that is 6 into 10 raised to 5, multiply by area, that is pi by 4 d square, stroke length L, that is 0.38, and RPM N by 2, that is 175, divided by 4 into 60,000. Okay, so final answer we get 38.075 kilowatt. That is the indicated power. This kilowatt power is generated inside the engine cylinder. Now we need to find out the brake power. The equation of the brake power is 2 pi nt divided by 60,000. Okay, so how we find T? So we have already the value of net brake load and the value of effective drum radius. Here you can see that they have given us net brake load and drum radius, drum diameter they have given us. So we will divide it by 2. So we will get drum radius, and by multiplying this we get the value of torque. Okay. So the answer will be 2 into pi, that is 3.14, n that is 350, and torque means the net load 1000 multiplied by 0.75 and divided by 60,000. So final answer will be 27.49 kilowatt. So this is the equation for the brake power. Now we have brake power as well as indicated power. So we can easily get the value of mechanical efficiency. Eta max is equal to brake power divided by indicated power. By putting value in this, we get the answer for mechanical efficiency, that is 0.722, and if we multiply it by 100, then we will get the efficiency in percentage, that is 72.2%. Now next is brake thermal efficiency. So brake thermal efficiency is eta Bt is equal to Bp divided by mass of fuel multiplied by calorific value. By putting the value of Bp, Mf and Cv, we get eta Bth brake thermal efficiency as 0.2229, that is 22.29 percentage. Okay. So this is all about this numerical. If you have any queries in this numerical, then you can write down your comment in the comment section. Okay. Next example is a 4-cylinder 4-stroke engine. Here the engine is 4-stroke engine and it has 4-cylinder, is used to produce 200 kilowatt brake power at 2500 rpm. Stroke to bore ratio is 1.2, that is L by D is equal to 1.2. If mean effective pressure is 10 bar, that is P mean is equal to 10 bar, and the mechanical efficiency eta max is equal to 81%, that is 0.81. Calculate bore and stroke of the engine. So the number of cylinder is 4, brake power is 200 kilowatt, the RPM is 2500, length by diameter ratio is 1.2, that means L is equal to 1.2 multiplied by D. Mean effective pressure is 1 bar, so we can rewrite as 1 into 10 raised to 5. Mechanical efficiency as 0.81, and we need to find out the bore, that is D, and stroke L of the engine. So let's start. First of all, we need to find out L and D, and we know that L and D comes in the equation of indicated power. So first of all, we need to calculate the indicated power. We have already the value of mechanical efficiency and brake power. So the equation of mechanical efficiency, from this equation we get the value of indicated power. So eta max is equal to brake power divided by indicated power. So we can rewrite this equation as indicated power is equal to brake power divided by eta max, and by putting the value of brake power, that is 200, and mechanical efficiency, that is 0.81, we get the total indicated power as 246.914 kilowatt. That is the value of indicated power. Okay. Now we are putting the value of indicated power. IP is equal to PMLAN divided by 60,000 multiplied by number of cylinder, that is K. Okay, because this is 4-cylinder engine. So the value of IP, that is PMLAN divided by 60,000, that is only for single cylinder. If there are multiple cylinder, then we have to multiply the value of the cylinders. Okay. So IP is equal to PMLAN divided by 60,000 multiplied by number of cylinder, that is K. By putting the value of indicated power, that is 246.914, main effective pressure, that is 1 into 10 raised to 5. The value of area, that is pi by 4 d square, 3.14 into d square. The length is 1.2 times d, and the RPM, that is 1250. The value of number of cylinder, that is 4 divided by 4 multiplied by 60,000. By solving these values, we get the value of diameter, that is 0.1465 meter. Okay. So if we have value of diameter, then we can easily get the value of L by L by D ratio. So L by D ratio is 1.2. That means L is equal to 1.2 into D. So the answer is 1.2 into 0.1465. So the final answer will be 0.1758 meter. That is the value of stroke length. Okay. So this is very easy numerical. You can solve more numericals like this. So next numerical is, the following data is available for 2-stroke diesel engine. This is 2-stroke engine. The bore is 10 centimeter, means D is equal to 10 centimeter. Stroke length is 15 centimeter L. Engine speed N is equal to 1000 rpm. Torque developed, that is 58 Newton into meter. Mechanical efficiency is 0.80, indicated thermal efficiency that is 0.40, calorific value of the fuel that is 44,000 kilojoule per kilogram, indicated power that is IP that we need to find out, mean effective pressure and brake specific fuel consumption. This all data we need to find out. So we have already discussed the indicated power and mean effective pressure, but we don't know brake specific fuel consumption. Is brake specific fuel consumption BSFC, that is equal to mass of fuel divided by brake power. So diameter D is 0.1 meter from the given data, stroke length L that is 0.15 meter, RPM is 1000, CV calorific value that is 44,000 kilojoule per kilogram, and torque developed that is 58 Newton into meter. Okay, so first of all we need to find out indicated power, mean effective pressure and BSFC. Okay, we have mechanical efficiency and they have given us torque developed. Okay, so from the value of brake power we will find out the indicated power. So first of all we will find the brake power, after then we will find the indicated power. So brake power BP is equal to 2 pi nt divided by 60,000. So by putting all the values we get brake power as 6.073 kilowatt. Okay, now we will put the value of brake power into the equation of mechanical efficiency. Mechanical efficiency eta mech is equal to brake power divided by indicated power. So indicated power is equal to mechanical efficiency brake power divided by mechanical efficiency. So the value of brake power is 6.073 divided by mechanical efficiency, that is 0.8. We get the value of indicated power, that is 7.59 kilowatt. So first the value we have already get the value of indicated power. Now we need to find out the mean effective pressure, and we know that mean effective pressure comes in the equation of indicated power. So from indicated powers equation we will get the value of PM. So IP is equal to PMLAN divided by 60,000. Okay, so the value of indicated power is 7.59 kilowatt. The pressure PM, area A pi by 4 d square. Okay, the L is 0.10 and RPM is 1000 divided by 60,000. By putting all the values in this equation we get mean effective pressure as 3.886 bar. Okay, so this is the value of mean effective pressure. Now we need to find out the brake specific fuel consumption. So the equation of brake specific fuel consumption is mass of fuel divided by brake power. So first of all we need to find out the value of mass of fuel, and in this problem we have the value of eta it. So from this value we will get the mass of fuel. So eta it is equal to IP divided by mass of fuel multiplied by calorific value. So we will get the value of mass of fuel as 1.5529 kilogram per hour. So that is the value of mass of fuel which we will get from the eta ith. So now putting this value in equation of BSFC, BSFC is equal to mass of fuel divided by brake power. So mass of fuel is 1.5529 divided by 6.073. So the equation, the value of BSFC is 0.2257 kilogram per kilowatt hour. So by this way we can easily calculate the value of BSFC. So if you have any queries in this numerical, so you can write down your comment in the comment section. You can practice more numericals at home. If you have any queries regarding that numerical, then you can also write down your comments related to that numerical in the comment section. Thank you for watching my video.